Okay, so we're going to use logarithmic differentiation right here. And I'm going to take the natural log of both sides. And as I'm taking the natural log of the square root of t over 3t plus 1, I'm just going to change that into the 1/2 power. And I'm not taking the derivative yet. I'm just going to use my logarithm rules. To expand this logarithm. So the power came in front, and now the logarithm I can split into two different logarithms, and when you have division, it'll be a natural log minus a natural log. And now we're ready to take the derivative. So now that we're taking the derivative, we have 1 over y dy dx on that left side. The 1/2 is a constant, and the derivative of the natural log of t is 1 over t, and the derivative of the natural log of 3t plus 1 is 1 over 3t plus 1. You then must multiply by that derivative on the inside, which is 3. And the first thing I want to do is, so I've done the calculus. It's just some algebra from here. I want to get a common denominator between t and 3t plus 1. So that would be t times 3t plus 1. And in that numerator, we would have 3t plus 1 and minus 3t. So now you would have, when you combine your like terms, you would just have that 1 in the numerator because the 3t's canceled, and the 1/2, 1 over y dy dx. So now I want to solve for dy dx, and you would just multiply both sides by y over 1. That could be thought of as y over 2, but I'm about to plug y in, so I'm just going to continue to think about it as 1/2 times y times 1 over t times 3t plus 1. So now all I need to do is plug in what y was. Y was the square root of t divided by 3t plus 1. When I plug that in, I'm going to separate the square root. Now, I'm not going to do it over the whole thing. I'm going to separate it into the square root of t divided by the square root of 3t plus 1. Okay, so in the numerator, I got a 1, I got 2 in the denominator. So notice that I got a few of the same bases happening. I have a t, that's to the 1/2 power. I have a t to the first power down here. And in the bottom, I have a t to the 1/2 power and a first power. So I'm going to, instead of the radicals, I'm going to write a fractional exponent. 1 times the square root of t times 1, that's just, t to the 1/2. I really don't technically need this 1 right here. But anyway, so I have a 2, and I'm going to call the 3t plus 1 to the half. I'm going to say times t times 3t plus 1. So this is what's about to happen. The bases that are the same, I gotta do some simplification. So t to the half and a t to the first. The whole half cancels with half of the t to the first and the bottom and leaves you with a half in the bottom. There was a half up top canceled with half of it in the bottom. So there's a half now in the bottom. The 3t plus 1 and the 3t plus 1, you keep your base and you add your exponents. So a half plus 1 is 3 halves. And don't forget your 2. And there's just a 1 up top. And we can leave it just like that. Okay? I really wouldn't want it. Now, it's super important to me that I see that you plug in y. I wouldn't want it left like this just because we have some of the same bases going on. Okay? So it's better to change those radicals into fractional exponents and simplify the bases.